Hello, I am Rob Prue, Agriculture Technology Systems Specialist with NDSU Extension, and I am here to talk a little bit about delta T and what is delta T. So simply put, delta T is the evaporative ability of the air, and it is defined as the difference between the ambient air temperature and what's known as the wet bulb temperature. And the easiest way, I think, to explain wet bulb temperature is to explain how a sling psychrometer works, which is described in this YouTube video.
To begin with, you take the wet bulb thermometer and dip it in water. You spin the sling psychrometer around. While you're doing that, the water is evaporating off of the wet bulb. You then read the thermometers. The dry bulb, in this case, read 24 degrees Celsius, while the wet bulb read 21 degrees Celsius.
So this sling psychrometer had a water-soaked cotton sock at the end of a thermometer. Once it was spun in the air, that thermometer read cooler than the ambient air thermometer did. And the reason for this is that evaporation is a cooling process. So similar to if you've ever gotten out of a body of water, like a lake, a swimming pool, even the shower, and allow yourself to air dry, you may notice that you felt colder because evaporation is a cooling process. So the wet bulb temperature measures that amount of cooling that occurs due to evaporation. So delta T could also be described as wet bulb depression, but again, it is essentially the evaporative ability of the air. In this example here, a 3 degrees Fahrenheit difference is actually quite small, represents a low capacity of the air to evaporate. If that delta T were larger, say 9 degrees Fahrenheit, that means that the amount of evaporation that occurred was able to cool that wet bulb down even more because the air had a greater evaporative ability. So the greater the delta T, the greater the difference between these two temperatures and the greater the evaporative capacity of the air. Thank you so much for your attention. To find me online, you can find me on Linktree.